In this question, we're going to talk about how we can isolate something that's a little tricky to isolate. This question is titled, how do we isolate system-level resources, specifically networking resources? And we're going to talk about things like SOCAT and DNS mask. We're going to talk about domain sockets, and we're going to talk about what happens when you need to rapidly prototype in multi-user environments. For example, I spin up a dev server, and I spin up a really beefy dev server. So I don't want to spin up two of them, one for me and one for the person I'm collaborating with. I want to spin up one, and we both use it. And I want both of us to be able to use Docker, and I want both of us to be able to spin up dashboarding tools or whatever the case may be. And those tools may need to bind against ports, bind against, create sockets. They may need to be APIs, REST APIs or web front ends, whatever the case may be. And I don't want us to clobber each other. So why don't we take a look? As a very simple example, I might want to run Python's HTTP server built in, but address already in use. I guess there must be something running, maybe from a previous presentation or a previous thing I was working on the port that is expected. So I'll just change my port to port 5000. And then I'll run, oh no, I can't run two of them on port 5000. I can only run one at a time. And you can think this is immediately something where I'm running into an isolation problem because sure, I could run one on 5000 and one on 5001, but am I going to really remember what number I'm up to? And if it's not just me working in this environment, but a colleague or multiple colleagues working in this environment, are we going to have a whiteboard that says, I'm 5001 to 5010, you're 5010 to 5015, and definitely don't use 5016 because that belongs to that person over there? That's not going to work. Now, if you know anything about socket programming, you may have encountered things like SO reuse address or SO reuse port, but largely that doesn't really apply to this case. It is the case that you can bind against the same port and the same address in multiple times, but here we do want these to be isolated. I want to start up my dev environment, my dev REST API, and I want you to start up your dev REST API, and I want mine to be off of whatever Git branch I'm working on, in whatever environment I'm working on, and I want yours to be the same, and I want them to be isolated even though we're on the same computer. Or I might be working on two projects simultaneously that both have fast API, REST APIs, and I want to start both of those at the same time because, I do a little bit of work, then I go off and do something else, and I come back and I want to start this and stop this and start this and stop this. What a headache. Well, what I might notice is typically when you start some service that's running, you're binding. And you're binding against this special address 0000. And this special 0000 indicates to bind against all available interfaces. Well, usually if I'm working in an environment like this, like for a dev process, I don't want to bind against all interfaces. I just want to bind against localhost because either I'm not going to serve this to the world. In fact, I probably don't want this to be world visible. I want this only to be visible by people who are currently on that machine or people who have SSH tunnels into that machine. And if I look at what my loopback interface allows me to do, we can see that in that loopback interface, we get IP addresses 127.001/8. That /8 represents how big of a block of IP addresses we have. You may have heard this in terms of things like netmask. This would be a netmask 255.000. But here's what you can think. If this is that IP address 127.001 written out in bits, I own all of these bits. Meaning, I own 127.001, I own 127.11, I own 127.201, I own all of these. Some of them are reserved for special purposes, multicast addresses and whatnot, but there's only about 2 or 3 of those. I own everything else within this block. I've seen a proposal for actually carving out some of the IP addresses in this block. I don't know if it's going to go anywhere. I suspect it wouldn't because that could break a lot of code and a lot of hardware and a lot of firmware, but people are desperate for IPv4 addresses these days. But as it stands today, you own all of these blocks, which means if I had 3 projects I was working on, which each had an HTTP server, I could bind against port 5000 on separate loopback addresses, 127.011, 21, 31, to my heart's content. But there's still this problem of now I have to remember which IP address, which loopback address am I using? And I could solve this in a very interesting way. One thing I could do is I could take something like my username, my host name, maybe the name of the project. I could hash them using something like XSH32sum, which would give me a 32-bit hash. I convert that hash into a numerical offset from 127.001 and just make sure that I skip certain key ones like the 255 at the very end. And what I could do is I could create a symbolic mapping based off of some very trivial hash function from my name and what host I'm on to a 127 address. And in fact, this is what I do. And so when I log onto a machine, instead of just randomly picking, oh, what's the next one in use? I have a well-constructed company-wide hashing mechanism that turns the project name, the username, and the host name into a 127 address. And then I'm free to do whatever I want within that 127 address to my heart's content. In this case, it's 203.116.117. And obviously, I might not want to memorize it or run this process every time, so I could actually register a domain name against this. I could say my project.username.host. Whatever my top-level domain is this address. And so I could refer to this symbolically. Or if I didn't want to go to that effort, I could run a local DNS server like DNS mask. And in DNS mask, I could populate it locally to that machine in just a file there, all of the different addresses for all of the different possible users for all of the different projects. And here you can see I'm taking this address and I'm mapping it to myloopback.example.com. And you can see if I do a dig and I set dig to this particular DNS server that's running on port 5353, it actually resolves for me, oh, my loopback, I know what that is. That's exactly that address. And so you can see I could have isolation. Now, obviously, the system administrator would have to set up that file and navigate that. You'd have to deploy it to all the machines. But you could see you could have a very nice isolation here. And you wouldn't even have to work with external DNS servers. Additionally, since many of you are on VPN, or many of you are in environments where you have some ability to push out DNS, you might not have to set this. You could just have a box off to the side that's centrally managed that has all of these DNS mappings. You don't have to make them public at all. They don't exist for anybody but your own little corner of the world. And when you VPN in, most VPN tools allow you to push DNS servers to users. You could push these custom DNS servers. So these addresses are only visible when they're connected to the underlying machine. And one thing that they might have to do, if they otherwise can't push this, is they have to update the resolve.conf, and this is where you find, your DNS servers. This doesn't quite work that well if you have things running on different ports, but since I'm an unprivileged user here, I can't run it on the official port 53. I'd have to run it on port 5353, but I think you get the idea. Now, there's something even more powerful that you could do. If you controlled the underlying application, meaning you could change that application. For example, you wrote the API and you control the entry point for that API. It's not a binary that you're just deploying with some configuration. You could tell it, don't bind against an actual port. Bind against what's called a domain socket, a named socket. You can tell your process, instead of having localhost 5000, localhost 8080, use this file on disk to represent a named instance of that connection. And when you think about it, the file system is a very common layering and isolation mechanism because you have one folder for each project. Within that, you can have subfolders and subfolders and subfolders, and you can keep things that are related together, isolated from each other. Well, what you could do, if your program supports it, and many do, your QEMU does, a lot of your basic servers do, you could say, bind against a test socket, a file on disk. Don't listen to an actual port, listen to that file on disk. And when you do that, you can see here, if I might have to sleep for a little bit more time to see the thing pop up. Okay, there we go. You can see that popped up. This here is a socket connection that represents connections to my server that does not take an IP address and does not take a port. And if I wanted to connect that to a port, I could use something like SOCAT. Or if I just wanted to interact with it directly, I could just use SOCAT to connect directly to that Unix socket, or I could open that Unix socket, with many programs, SOCAT and NC and so forth and so on. And you can think this is another really nice isolation mechanism because that file system and that directory structure is a commonly used, well understood isolation mechanism that we use all the time, that doesn't tie up a single unique privileged system resource, but instead turns that into something that we're very familiar with that can be, you could have 1 million sockets if you want. There's no limit, even though there's a limit. There's only 65,536 ports, and there's only so many addresses under 127.0.0.1/8. But how many files can you have on disk? As many as you want. There's a file system limit for these, of course, but it's much higher than the number of ports that you have. Additionally, if you wanted to expose this to the world, this SOCAT tool is so useful. It's like the Swiss Army knife of connecting files on disk and different protocols, different sockets. You can connect UDP to TCP. You can forward things. You can connect Unix domain sockets to TCP sockets. Here, what I'm doing is I'm starting my service against this domain socket so it doesn't tie up any system level resources. If I have multiple users, they are completely isolated from each other. And then what I'm going to do is I'm going to tell SOCAT, you know what? Take port 5000 on a specific IP, maybe an IP that I came up with using the previous process and connect it to this test socket. And when I do that, now I can communicate with this process either via that socket on disk, that file on disk, or via this port with this particular IP address. You can see this is with SOCAT and this is with NC. And so there you go. It is in fact possible with a little bit of support from your underlying applications to isolate even system level resources like ports that you can bind to when you are launching API servers or web front ends or whatnot. And this is something that I do all the time because dev servers aren't cheap, especially the really beefy ones that will deal with the super slow dev code that I write in debug mode with all of the debugging symbols in there and all of the source maps and whatnot. Well, they're not cheap. I only want to run one of them, but I want all of my users to simultaneously be able to use all of them without clobbering each other. And also, I have multiple projects going at the same time. I don't want to have to remember, is it port 5000, 5001? What am I up to? Did this thing shut down? Did I leave this open? I just leave everything open until I'm ready to close it down and do a git commit. But I don't have to worry about it too much because these isolation mechanisms help me.